Okay, so this is part 3. We're learning the rational root theorem. This works when you have a polynomial that has integer coefficients. So that means the numbers in front of x cubed, x squared, x to the fourth, so on, are all integers, not decimals or irrational numbers. So if it's in that form, this works, okay? It means that every solution has the following form. So basically, what this is saying is it's letting us find all the possible solutions that they could be, and then we can choose from that narrowed down list. It at least narrows down. Instead of going from every possible number, we now have a smaller list. It's not necessarily the smallest list we'd like, but it's smaller. So here's how we find this. So the P says it is the factors of the constant term a sub 0. Okay, so basically it is the factors of the constant. So like down here, the constant is negative 24. Now we don't have to worry about the positive or negative at this point. So we're just going to be like, okay, P over Q is the factors of the constant, which is 24, over the bottom is the factors of the leading coefficient, a sub n. So that's the leading coefficient. So the leading coefficient is 1. In front of this x cubed, there's a 1 right there. So that's over the factors of 1. All right, so think about this. The factors of 24, things that multiply to 24, are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Those are all the factors of 24. Now the factors of 1 are easy. It's just 1 because 1 times 1 is 1. So what this tells us is that the possible zeros can be 1 over 1, 2 over 1, 3 over 1, 4 over 1, 6 over 1, 8 over 1, 12 over 1, and 24 over 1. Now it feels silly to put over 1 every time. I'm just showing you that because what if the leading coefficient was 2? Then the factors would be 1 and 2, so you'd have a lot more options. So that's why I went ahead and wrote that out. The other thing is there can be positives and negatives of both because it could be a positive 2 and a negative 2, positive 3 and a negative 3, so on. So every single one of these is plus minus. So basically, the possible factors for this polynomial are plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 4, plus minus 6, plus minus 8, plus minus 12, and plus minus 24. Now, the 1 feels really silly on the bottom, but it's there because if your leading coefficient isn't 1, then it absolutely plays an important part. If your leading coefficient is 1, then it really is kind of a moot point and it doesn't really need to be there. So just watch out for that. So now, how we go from there to finding the zeros. This is kind of annoying, so we'll get better at being a more educated guesser. But what we do is we test a 0 until we get 1 to work with synthetic division. So like I'm going to first just test 1. So what that means is I'm going to have the 1 here. Now I'm going to use this polynomial right here. So remember, set up your synthetic division. The leading coefficient's 1. Coefficient of x squared is 1. Negative 14x and minus 24. I don't need any placeholders. All right, drop the first number. Multiply, add, multiply, add, multiply, add. I know right now it's going to have a remainder that's not 0. So as soon as I figure out the remainder's not 0, I can quit. You don't have to finish it if you're like, hey, the remainder's not 0, this isn't going to work. Okay, so 1 did not work. All right, so now let's try another one. Let's test negative 1. All right, now one thing about it is once you set it up once, it's really easy to set up again. All right, so go through your synthetic division process. So right there, I know I don't have a remainder of 0. So negative 1 is not going to work either. So I know that 1 and negative 1 are not zeros. So now let's go ahead and let's try 2. All right, so I'm going to test 2. So if I have the 2 there, all right, synthetically divide it. So that's negative 8. 2 times negative 8 is negative 16. Right there, I know that is not going to be a remainder of 0. So keep going. Now let's test negative 2. And you can see what I mean about sometimes it's really irritating if you don't find one very soon that works. It can be a little frustrating, but like you'll totally get there. So 1 minus 2 is -1, multiply, that's 2, add, that's -12, multiply, that's 24, add, that's 0. Okay, we have a winner. So what that means is that if -2 works, it means that -2 is a 0. So if -2 is a 0, that means x plus 2 is a factor. Okay, now the solution to when we did the synthetic division, this is going to give us another, like once we divide it by x plus 2, it gives us what's left. So remember that this is the remainder, constant x squared. So the polynomial that's left is x squared minus x minus 12. Keep in mind, we used this skill in the first half of chapter 4, so this is not a new skill, it's just applied in a different way. So now I want to continue to factor. I'm not going to continue to do synthetic division if I can factor it from where I'm at, which I can. So it multiplies to -12 and adds to -1 is -4 and +3. So let's make that +3 and -4. So that's the factored form. So that tells me that my zeros are -2, -3, and +4. And that is my solution. Okay, I know that sounds crazy, but let's go ahead and try another one. So this says, example 5 wants us to find the zeros of the polynomial function using the rational root theorem. Now remember, the rational root theorem lets us say, first of all, on the top, we have our factors of the constant, and the constant is 20. And then on the bottom, you're going to have the factors of the leading coefficient. And our leading coefficient is 1, which is awesome because it makes this so much easier. So really, you don't have to use the 1 because the factors are just 1. So the factors of 20 are plus and minus 1, plus minus 2, 4 goes into 20, 5 goes into 20, 10 goes into 20, and 20 goes into 20. So 1 times 20, 2 times 10, 4 times 5. And then positive and negative of everything. Okay, so now once you have that list of possibilities, you go from that list and you test factors until you get one, or I guess zeros, until you get one that works out. So I'm just going to start and I'm going to test one. And like I said, when you find one that works like really quickly, it's awesome. You're like, hey, this works great. And then sometimes when it goes on forever and you're like, I'm just not finding one, it can be, feel a little inefficient, but we will get more skills as we continue. Okay, so let's do synthetic division. Drop your first number, multiply, add. Multiply, add. Let's see, that'd be 4. Multiply. Okay, that's not going to be a remainder of 0, so I'm quitting on that one. Let's test -1 next. All right, 1, -8, 11, 20. All right, drop the first number, multiply, add them, multiply, add them, multiply, add them. Okay, hey, this one, see how we got a 0 much sooner. So a remainder of 0 tells me it works. So what that tells me is that if one of my zeros is -1, that means I can factor, and the factor that gives me a 0 of -1 is x plus 1. Because remember, when you set that equal to 0, you get -1. And then, remember the part of the synthetic division when we had divided, this right here is going to give us the other piece, the other factor, which is x squared minus 9x plus 20. Now, you can synthetically divide again the x squared minus 9x plus 20 and you can test 2 and -2 and so on. But honestly, this factors very easily, so why go through that when I can figure out what multiplies to 20 and adds to -9 very easily? And that's -5 and -4. So there's the factored form. So that means my zeros are -1, +5, and +4. And so that is the zeros using the rational root theorem. So the rational root theorem isn't necessarily like ideal, but it's a good place to start. It gives you a list of numbers to go off of. Instead of just taking a wild stab at numbers, it at least gives you a list of what the possibilities are. It narrows it down somewhat for you, so you at least have a place to start.